This is the video for section 13.2. We talk about reflections. So, as we talked about in the last video, a reflection is an isometry. So, isometry is some transformation, something we do to it, but it keeps congruency. So if we take a figure and then we reflect it, the resulting figure, the image, is congruent to the pre-image. So, what a reflection in our daily lives, we see them all the time. Anytime you're looking in a mirror, you're even the water as a mirror, as in this picture. Definition of a reflection is that it pairs each point in a plane with another point, the image, or P prime, in such a way that L is the perpendicular bisector of that segment P prime. And we'll talk about that a little bit more as we go a little bit later in the video. I want to show you this little app. So this is a line of reflection, and I can grab a hold of it. You can see what happens. I can even overlap, right? That is the line of reflection. I can move these points around and you see what happens. And so there it is. If it's on the line, it's itself, its image is itself, right? You notice that if you look at the line going from C to C prime, for example, and I'm sorry that I can't actually draw on this program or it'll do something else, but that line from C to C prime, and you look at that line of reflection, that line of reflection cuts it right in half. Right, so it's equal amounts. You see that it's equal amounts on either side of that line of reflection. So the reflection is different from the other isometries that we did in that it reverses the orientation. It flips it, right? And translation and rotations did not flip it. It stayed in the same orientation, but it moved it. So here's a few places that we might see. You might talk about folding a piece of paper. You have half the image and you're trying to draw the same thing on the other side. That's a good way of seeing what a reflection is. And when we were in the classroom, we used the mirrors. If we were in the classroom today, I'd probably pull out the mirrors so we could talk about reflections with them. But that's what it used, as a reflection. And by using a reflection, we were able to especially make perpendicular lines. They worked really well with the mirror. So reflections in a coordinate plane are pretty easy as long as we have a pretty easy line of reflection. So one of the axes, or the line y equals x, and you actually did some reflections with line y equals x when you were in algebra and you did inverses, right? So if you look at the point 1,4, which is right here, right, and the reflection is the point, this is 1,4, the reflection is 4,1, and that made it directly across that line of reflection. Right, so it's equal distance across, and here we have negative 3, 0 is B, and so B prime, or the image, would be 0, -3. So it's directly across. Sometimes, though, we can look at it because it's on this grid. We can figure it out. So this is the first one on your paper that there are 3 there for you to do. This is reflection over the line L, which is that line. For some reason, the L did not transfer over here, but we are looking at the perpendicular distance, right? The line that's perpendicular to the line of reflection and the same distance away. So this is 1 away, so the other side gets to be 1 away, right? So that's x prime. X is 2 away, so we need to go 2 away over here. That's going to be y prime. And then z, well, 1, 2, 3, 4, 5, 2, 3, 4, 5. So that will be z prime. And there is our triangle, which is congruent to that first triangle, right? So there are 2 more for you to try. I'd like you to pause the video, go see if you can draw out those reflections, and then come back and we'll see if you did the same thing I did. Okay, so I hope that you did it yourself. This time the line of reflection is vertical, so we're going to do all these horizontal lines to figure out where they are, right? Go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one is 1, 2, 3, 4, 5, 6, 7. 7 right here. That's our E. And 1, 2, 3, 4. That's going to be right here. And there's our reflection. And hopefully you do this one as well. This time it is a diagonal line. I still should be able to tell, since it's a 1 here, I should be able to draw the perpendicular way, right? So I'm going 1 whole diagonal and half a diagonal, so I got to go the same distance up here to get my t prime. This is 1, 2, oh, come on. 1, 2, 3, 4 diagonals. 1, 2, 3, 4. And that is v prime. And this one, which is actually, so there we have our perpendicular. Oop. So take a moment. We already kind of mentioned these, so it shouldn't take too much, but pause the video and take your ruler and protractor or whatever. I want you to look for the image and pre-image, something that kind of goes with it. I'm especially wanting you to look at those lines. We've probably already talked about it, so I'll just, the fact that if you draw that line, then DE is the perpendicular bisector, right? And it is also the perpendicular bisector of that segment. and it is also the perpendicular bisector of that segment. So that's the key I wanted you to see, that those segments connecting the two, all of them have the same perpendicular bisector, and it is the line of reflection. The line of reflection is perpendicular, and it goes through the midpoint. All right, so you know what this, knowing that it is the perpendicular bisector, that the lines are perpendicular, you could use your compass and straight edge to construct a triangle when we don't have a grid, so it would be kind of hard for us to be precise. But with the compass and straight edge, we can do it. Okay, so this is the Robo compass. So I'm creating the triangle first. And I'll create the line of reflection, and then we'll reflect it. So here's the line we're going to use. DE is the line of reflection. So what I'm doing here is creating a perpendicular bisector with those 2 points there, right? Because I left the compass the same distance, so I know that AF is the same as the new point G, which it's going to mark in a second here. And so the so I know that length from the line to A is the same as from the line to G because of how I did those arcs. Okay, so the next two lines I didn't use the compass to do it. It takes a long time to create those. I just had it create perpendicular lines, and so we're marking perpendicular lines and marking that point. Now, so can you see why we needed that arc there with the compass? That was marking that it's the same distance from B to H as it is from H to the new point, which is I. Right? So it makes it the same distance, and now I'm going to do the same thing here, create a perpendicular line, and then we're going to make the same distance from C to J as it is from J to K. So my new triangle, GIK, is congruent to the triangle ABC. Oh, for heaven's sakes. Okay. So the other thing we might construct is, if I give you the two triangles, can you construct the line of reflection? So the things we know how to do really well with a compass is to create, So with this segment right here, if I construct the perpendicular bisector, that will be the line of reflection. And I can actually choose any of these sets of points. I could do C prime and do that perpendicular bisector. Or I could do A prime and do that perpendicular bisector. So what I want you to do is, using your compass and straight edge, I want you to do those two constructions. First one is to actually do the reflection, which is what I just showed you on the Robo compass. And the second one is, given the two reflection, the image and the pre-image, construct that perpendicular bisector. So this section also talks about a glide reflection. They sort of treat it like it's a separate isometry. We can think of it that way if you want, but it is basically a translation and a reflection kind of combined. It's just that it's a special kind of, it's not just any old combination of a reflection and a translation. This is translating along a vector, and then the reflection is over a line that's parallel to that vector, and that is what we call a glide reflection. So it's also an isometry because the image is congruent to the pre-image. Okay. So some of the things that we use reflections for, you may have used it if you did the indirect measure activity by using a mirror. Then you are using the reflection in that mirror, and the thing that we note is that so if here's your mirror on the ground here, a light comes in, or your eye, your sight comes in here, right, and reflects off here. What we know is this angle that it makes, we call it the angle of incidence, and it's the angle between the perpendicular to the mirror and the incoming, the light hitting the mirror, is the same as the way it reflects away. And that combination of hitting and reflecting off of something gives you that same angle. And it's not just light. So if you've ever played pool, the ball hitting the side and bouncing off, it is a reflection, and that angle of incidence is the same as that angle of reflection. And that's what it just talks about. So remember back when we did a bunch of congruencies, and you may have had figures, then we were deciding whether they're congruent, and we would look for sides or angles that we knew, and they could be all over the place, right? They could be flipped, they could be backwards, inside out, whatever, as long as we had the angles and the sides the same. And if they are congruent, then there is a way to do a combination of these isometries to get one onto the other. And so there were basically three, right? The translation, the rotation, and the reflection. And by using some combination of them, we can get any congruent figure onto some other congruent figure. That is all we have in this section. Hopefully you won't have any trouble doing that homework and start thinking about all three of the isometries. We have one more section that is on another transformation, but it is not an isometry. So it gives us similar things, but not congruent things. So I'll see you in class, hopefully, if you